All right, so we're going to go through these words. A lot of these words you do not have to understand in depth what they are. Some of these words you will already know what they are. The purpose of this is not for you to study these definitions. The purpose of this is for you to have a better understanding of the word, so that when it comes time to discuss them in class, you have a better understanding and you don't get lost completely. So classification, how to organize stuff. If you go into a grocery store, the vast majority of grocery stores are going to be set up very, very, very similarly. People who set up grocery stores set them up on purpose. So where's the meat typically at? Do y'all know in a grocery store? Where's the meat typically at in the grocery store? Just say it.
In the back of the store?
No, almost always it's in the back of the store. And normally, almost always, the produce, like fruits and veggies, are either in the store as soon as you go in there to the right, or as soon as you go in there to the left. Around the edge of, like the walls of the store, the edges of the store, they're almost always whole foods. Foods like that you could find in nature. Like from an animal, directly from an animal, or directly from some kind of plant. The food on the inside of the store, like on the aisles, are normally foods that are processed. So there has to be some machine or something that is done to that thing. So think of like a waffle. There's no waffle tree. There is no ketchup tree. Even though it's from tomatoes, there's a bunch of stuff in those things. So generally, if you stay to the outside of those, the grocery store, you're going to have one type of food. And in the middle of the grocery store, you're going to have a different type of food. Okay, say you're looking at ketchup. How far away would you expect milk to be? Is it going to be on the same aisle as ketchup?
Yeah.
Probably not. What about mustard?
Yes.
Probably. So in your mind, you already understand how the grocery store is set up. Now, Walmart is going to look different than Publix, and one Publix may look different than the other Publix. But in general, ketchup and mustard and pickles probably going to be on the same aisle. A can of baked beans and a can of corn is probably going to be on the same aisle. But you would not expect diapers and ketchup and charcoal and milk and an apple to be on the same aisle. And that's because when we group things together, when we start building something, as humans, it helps us to understand how they are classified. You know, we may not use that word, but that's what's going on. We're grouping things in similar groups. So would you expect a beetle and a fish to be in the same group? Well, it depends. How general are we talking? If we're talking like specific thing, a beetle and a fish?
Yes.
Beetle and a fish are very different, but how are they similar? What are they both? They're both what? They're both animals, and they're also both living things, right? So if you think of a tree, like, you know, trees generally they have a large base. An old tree, they have a large base, and then somewhere they've got large branches that are coming off of that tree. So on this tree, we've got a large trunk, and we've got 3 big branches coming off. Everything on that tree is on one of these 3 branches, correct? Everything, all the leaves, we'll say all the leaves are on one of those 3 branches. But if I said, hey, pick me a leaf off of this branch, and it's just this one massive branch here, do you know which leaf I'm talking about? If I said, hey, pick the leaf on that branch, do you know which leaf I'm talking about? Why? There's a ton of them. And that's why I said, if I say something like that animal, and there's 300,000 animals, you don't know which one I'm talking about. So this is very, very general. Very, very general. And out there on the very, very edge is going to be what? What's the opposite of general? Specific. Specific. So out here where the leaf is, there's a tiny little twig with maybe 3 or 4 leaves on it. And that's going to be very, very specific. And we'll come back to this in just a minute. But that is how we classify living things. We classify living things with this kind of model. We'll get to that in a second. So a dichotomous key. Go ahead and write down a dichotomous key. So for classification, you should have how to organize stuff. Very generic definition. Dichotomous key. Tool for identifying stuff. It's a tool. Go ahead and write that down. Tool for identifying stuff. If you're trying to shorten it, you could say I, capital D, apostrophe ing, like identify, IDing. Tool for identifying stuff, and I want you to put a semicolon. You know what that is? It's like a floating period with a comma under it, a semicolon. Put splits into 2. Splits in 2. What is it? Is shift period? No, shift. It's the button beside the L. Okay, just push the button beside the L. The button beside the L is a semicolon. So, who in here plans on getting married? You know, let's not ask that question. Imagine you are married, and then you find out that your spouse was married to somebody else as well. Would you be like, you know what? It's not a big deal. It's fine. No. Now, if you were going to hang out with somebody and you found out that they were going to hang out with somebody else and they're just a friend, that's not that big of a deal. If it's your girlfriend hanging out with somebody else and that you think that they're attracted to or that that's their boyfriend as well, that becomes a problem for you, right? Do you know why? There's two words that explain that. You want a relationship that is mutually exclusive. Have y'all ever heard those words before? Mm-hmm. Mutually exclusive means you're excluding everybody else. So Miss Hurley, the way that she views me and the way that I view her, she is my girl, and there's nobody else. Do y'all understand? There's Miss Hurley, and then there's everybody else in the world. Do y'all understand that? There's Miss Hurley, and there's every other girl in the world. That is mutually exclusive. You can't be in both of those groups. So if I draw two circles up here on the board, here's a circle, and over to the side, there's another circle. Can you be in both of those circles at the same time? No. But what if I draw it like a Venn diagram, where you have a circle and a circle kind of overlapping? Can you be in both of those circles at the same time? Yes. So for the word dichotomous key, a dichotomy means that it's two mutually exclusive groups. They have to be separate. And a dichotomy looks like this. It's kind of like an upside-down skeleton of a tree. It keeps splitting up into two. Have y'all seen something like this before? Yes. Family trees kind of look a little bit like this. Maybe a bracket, like a sports bracket. Oftentimes will look like a dichotomous key. And we'll talk more about that in the future. But a dichotomous key is a tool for identifying stuff. It helps you ask questions so that somebody who's already identified that can help you understand it. And again, we'll go through that in more detail later. All right, domain, kingdom, genus, and species. Those are the next four. I want to pause the video. If you're for the video, you can go ahead and listen or go ahead and write those down. So domain is the most general, and species is the most specific. And so you have domain, kingdom, and then you have a bunch of other stuff, and we'll talk about those eventually. But domain and kingdom are important, and then genus and species are very specific. Which genus and species will take us to this discussion. We're going to skip taxonomy. Binomial nomenclature. So if you want to sound really smart when you go home today, and if somebody at home asks you, hey, what'd you learn today? Just act like you were really bored and it was so easy. Say, what did we... I think we talked about binomial nomenclature, and I'm just tired of that. Like, I already know so much about binomial nomenclature. Or you can act like it's very easy. You probably don't know what binomial nomenclature is now, but I'm pretty sure after we talk in just like maybe 2 or 3 minutes, you'll be able to understand that. So, binomial nomenclature. What does the word bi, what prefix is that? Binomial. What does bi mean? Two. All right. Nome, and then clature. So, clature is like a system. Some kind of system. It's a system. We'll just say that. It's a system. So, binomial nomenclature. Nome is in both of those words. Y'all see that now? Binomial nomenclature. Binomial nomenclature. So binomial nomenclature. Bi means two. Nomial is kind of word for part. We're going to pretend like nome and binomial is the same thing as nome and nomenclature. It's not the most accurate thing, but again, I'm just trying to help you remember what these words mean. So, does anybody know what nombre means in Espanol? What? What? Name. Nombre. So, binomial nomenclature. This is literally translates into, or we're gonna pretend that two-name naming system. Two-name naming system. Now that means that everything in this binomial nomenclature has how many names? Two. Y'all know what the two names are? The most specific you can get. We just talked about. What are they? What two words would we just say are very specific? Huh? Genus and species. So you've heard this before. I'm almost positive. Homo sapien. Y'all know what that is? Y'all heard of that strange creature? It's taking over the world. Y'all know what it is? Humans. Yes. What about Canis lupus? Y'all heard of that before? That is something you might have at home. A dog. What is this Canis? What does that sound like? Canine. That is a Latin word. So we'll talk about scientific names later, but they're always in Greek or Latin, and there's always two names. And when you see them spelled, the first letter is always capitalized, like Homo, H, in Homo sapien, and everything else is lowercase, and you'll oftentimes see them kind of tilted, italicized. So they're in it, and they're in Latin or Greek, and the way you write them is like this. Do humans have binomial nomenclature? Like, do we have a two-name naming system in America? How do we name ourselves?
Mammals and humans.
No. How many names do we have? Let me ask the question better. 3. So what would we have if we were to use this same phrase? We would have a trinomial nomenclature because we have first, middle, and last. Now, some of you I know have 4, 5, or 10, or whatever. But in general, Americans generally have 3 names. And that would be a trinomial nomenclature. This is binomial nomenclature. All right, so it's literally beside that, I want you to write two-name naming system. Two-name naming system. It literally means, if you were to break up those words, I think it means two-part naming system. But you have my permission if you want to try to remember it just as a two-name naming system. Binomial nomenclature. So what did you learn today?
Binomial nomenclature.
Yeah, we kept talking about binomial nomenclature, but I already knew all that. So, all right, protist. Protist. This is that 4th kingdom that I was talking about. Protist is a kingdom. I'm going to write this down. A kingdom that has a nucleus. Kingdom. Just do the best you can. Kingdom that has a nucleus, but it's not a plant/animal/fungi. Write it down. Kingdom that has a nucleus, but it's not a plant or animal or fungi. And again, we will talk about these things later. I just want you to have an idea. It is a kingdom of life. You have plants and animals and fungi, and you have this weird one called protists. I'll say it again. Kingdom that has a nucleus, but not plant, animal, or fungi. Let's go to the next one. Arche. Does anybody know what this word means? Ancient. It literally means ancient. If you want to write ancient, that's fine. If you want to write really, really, really old, that's what I wrote. Really, really, really old. Ancient. Arche. So what is the study of ancient things called? Just say it. Archaeology. Y'all heard that before? What is a person who studies ancient things called? Archaeologist. Archaeologist, yeah. So arche means old, ancient. Very, very old. Ancient. All right, next one. Eukaryotic. What does that mean?
It does have a nucleus.
All right, so what's the way you can say it with just 2 words? Has nucleus. That's what I wrote. If you want to write something else, you can, as long as that's accurate. Has nucleus. So what is prokaryotic? No nucleus. Pro is no. That's right. Next one, trait. A trait. Now, you should remember this from genetics, but in case you weren't here or you don't remember, a trait, I wrote down what something looks like. Now, you could write down phenotype. I understand why you put that, but we're trying to keep it super simple. Super simple. What something looks like is a trait. So, producers, I wrote make own food. Now, that's not even a good phrase. It's definitely not a whole sentence, but that gets the point across to me. You can write it. You could have an S on there if you want to. Makes own food. But a producer makes their own food. They convert sunlight, generally it's sunlight, into sugar. What's that process called? Do you remember? Photosynthesis. All right. Next one is consumers. I wrote get food from others. You want to write energy from others, that's fine. But I wrote get food from others. This is us. We are consumers. We are consumers. And then the last one is decomposers. Decomposers is breaks down. I wrote breaks down others. So producers make own food. Consumers get food from others. And decomposers, I wrote breaks down others. Now, consumers and decomposers are both what? Do I remember what they're called? Starts with an H. We talked about this like the second week. Heterotrophs. Good job. Heterotrophs. Good job, David. Heterotroph is just an organism that gets its food from others. Decomposers is kind of an odd type of heterotroph. All right, last four, two sections. Sexual and asexual. Sexual and asexual. So for sexual, I wrote 2 parents. So go ahead and write that out. For sexual, 2 parents. And this should be a review as well for you. 2 parents. And then I drew an arrow, or I typed an arrow, and I wrote unique offspring. Do you guys know how to draw an arrow? It's hyphen, hyphen, and then the arrow button that's above the shift button, I believe. All right. So 2 parents, and then I said draw an arrow, and then I wrote unique offspring because the offspring is unique. So 2 parents, and they give you, so 2 parents, and then point to an arrow to unique offspring. 2 parents give you unique offspring for sexual, and asexual is 1 parent gives you a clone. 1 parent and gives you a clone. It's an exact copy. And that should remind you about genetics. That should remind you the benefits and the negatives of both of those. But that's for sexual and asexual, that's what you need to remember. And multicellular and unicellular. These are easy. I wrote the little greater than sign that I'm talking about, that you just use for the arrow. I wrote greater than 1 cell. So multicellular, I wrote greater than 1 cell. And in parentheses, maybe many cells. Because I don't know of any organisms that have 2 cells. Like just 2 cells. Like I know there's single-celled organisms and there's cell organisms with thousands and thousands, if not millions and billions of cells. So greater than 1 cell or many cells is multi, and unicellular is only 1 cell. Only 1 cell. And again, all of this, you do not need to study these words yet, these definitions at least. But what you do need to do is understand what these are just generally. So hopefully that's already happened in class. You don't have to look at it at all. And then when we talk about it in class the next time, it will make more sense to you. At least it'll be familiar to you. Like if you had never seen a horse, and I explained it's a big dog that eats grass that you can ride on top of, you would understand the general idea of what a horse is, even if you didn't get exactly what it was.